Right, so I'm going to cover 1.3 computer networks, connections and protocols, and we'll start with 1.3.1. So in this section, we're going to look at the hardware needed to create a computer network, as well as the factors that can affect the performance. We'll also cover the basics of the internet and network topologies. So let's have a look. Right, so first of all, why do we even bother to connect computers together? Well, basically, these reasons. So essentially, you can share resources like the internet, printers and files, which is the main reason that you have a network in your house, no doubt. Also, the internet is a network, don't forget. So without that, you couldn't be playing games. It allows roaming access where you can use any computer and your documents are there. So in an office or school, you just walk over, log in, and your documents and settings are all there. Now this is one that the kids normally don't get, which is that a system manager can install or update software easily. If I want some software installed at the school, I just email the technicians and they click a few buttons and then it ends up being installed. They don't have to go to every single machine. And this is kind of the same thought process with the backing up of data. If the data was stored on each computer, then they'd need to go and get every computer's data one at a time. But given that it is on a server, they can just back that server up automatically overnight and it's done. And last but not least, another main, well there are lots of them, but another one that's quite useful is you can have levels of access. So you can give different users that log into your system a different permissions. So some can write or read from this folder, some can't even see this drive, some can load this program, some can load that program. So there are lots of reasons this might be useful in a workplace. So you can allow your lower level staff to only access certain things. Maybe they don't get the internet because they don't need it and you don't want them to have it, and so on and so forth. So that's a reason to connect computers together. So this is probably known by you all now. But anyway, so the types of network we're looking at in this course are LAN, which is a local area network, just like you probably have in your house, and is a network in a single geographical location, and you own all the hardware that's involved, okay? You physically own all of it. A wide area network, just like the internet for example, is a network in more than one geographical location, and you do not own all the hardware involved. You will be using other hardware owned probably by other companies. Right, so let's look at what affects a network's performance, okay? So it's quite easy really to think about it. Basically, how good the hardware is, how much bandwidth it has, and we'll cover bandwidth a bit later. But basically, the faster the hardware, or the better the hardware, the better the performance. The amount of interference is important, especially if wireless. If you've got a lot of electrical equipment and you've got a lot of thick walls, that's going to really affect the performance of your network. The number of users, more bandwidth used, will slow down the network. The range, especially if wireless, if you're far away, you're going to have a weaker signal, and that's going to affect the performance of your network. And last but not least, the transmission media. So basically, how are you connecting to a network? Wired being faster. So if you've got a wired network, it should, in theory, be faster than a wireless network. In theory. Okay, so there's them. So right, we're going to move on to the different pieces of hardware that are required to connect to a network. This one's on a local area network. So a network interface card is basically either the circuit board that's on the motherboard or the USB dongle or whatever you want to call it. It's the piece of equipment that allows you to get access to a network. So whether it's a USB dongle that does wireless, and that's normally called a wireless network interface card, or whether it's the bit of your motherboard that's got the Ethernet connection to it that allows you to connect wired. But whatever it is, it's a circuit board rather than a card itself, or some circuits that actually enable you to connect to a network. Right, a switch is basically a computer that will allow you to form a network by connecting devices together. What it does is it switches, called packet switching, the packets to the correct computer. So if you want to talk to computer 17, it sends the information to 17. That's basically it. Now a router is a bit like a switch, except it does one more job. It does exactly the same thing a switch does, but it also allows you to connect networks together. So in your house, you've got a router, so you've got a network of computers in your house. If the internet, for example, goes down, you still do have a network of computers. So for example, I could still print my printer if the internet went down. But the internet is another network, and when you're joined to that and it's working, the router will combine the networks. It will reroute the information to the appropriate network. A wireless access point is like a bit like a router, except that, well, maybe that's not a great example. Essentially, it's what when you're in school, if you were using the Wi-Fi at this school, then when you connect to the wireless access point, it isn't the router you're connecting to because the school is so big. It hasn't got 20 routers. I mean, we have a server, which is even advanced above a router. But let's say we didn't. Let's say we have a really big house and we've got a router in it, but they're too far away most of the time to connect to it. So you can have what's called wireless access points. And basically, you can join them and they can be used to extend the range of a wireless network, basically. We've been through transmission media. And that's just basically the how is the data carried from one place to another? Is it wired using Ethernet, fiber optic, or is it wireless using Wi-Fi, theoretically Bluetooth, but probably not for a proper network. Yeah. So moving on, we're now going to look at these part here. So DNS, a lot of you have talked about DNS in lessons, so we should know it. But essentially, DNS, domain naming system, it converts a URL, Uniform Resource Locator, which is the web address for those, fancy word for a web address, into an IP address. Because obviously, that is really what it should be. Now, that is what the computer wants, but humans want something more like this. So that's basically the idea behind DNS is it allows people to give out words and then the DNS server will convert it to an IP address. And these are the steps for it. And basically you enter that into a web browser. The web browser sends the URL to the DNS server. The DNS server replies back with the website's IP. The web browser requests the website from the server. So it requests the website from this IP address and the website sends the server back. The website server sends the website back and the web browser shows it. That's basically the steps. Okay, I mentioned bandwidth earlier and it's something that some kids said they didn't know too much about. But essentially it's how fast data can travel on the network device. It's measured in bits per second. So each device, rather than the network itself, has a bandwidth. So the cable has a maximum bandwidth, the router will have a maximum bandwidth, the network interface card will have a maximum bandwidth. If you've got a 1 gigabit router, but you've only got cable that supports 100 megabit, you're only getting 100 megabit. It goes down to the lowest one that you use. These are the main ones that are used. You've got twisted copper wire, which is what you might think of as Ethernet cable, but it's really called Cat5 cable or Cat6, Cat7. And that is getting faster, but it has quite a short range. Ethernet cable, it gets signals, speed drops over a distance. Not as short as Wi-Fi, but it will drop. So you can get up to 100 gigabits at short range, but normally it's about 1 gigabit per second. Fiber optic cable, very fast, over 40 terabits per second, and it goes very long range, really long, really long. Yeah. And home Wi-Fi wireless is normally around 250, but you can get up to 1 gigabits. But often with Wi-Fi, you don't get the data they say. Whereas with Ethernet, if it says it's 1 gigabit, you get very close. With wireless, you don't. And also it changes variedly. It suffers a lot from interference. Yep, so that's transmission media. Okay, so we've got network topologies. Okay, so you've got star network and you've got a mesh network. But yeah, that's basically what it is. And it's about how they're connected together. It's the arrangement or pattern of topology. So let's look quickly at a star. This is the same as the one in your house. Okay, probably. Each node is separately connected. Therefore, a failure of one node does not affect the others. Okay, so if that one dies, it doesn't affect this one. It can't talk to that one, but it doesn't affect it. New nodes can be added simply by connecting them to the switch. So it's quite easy to add a new device because you've only got to connect it to the one place. And they tend to have a higher performance than, say, others because the message sort of goes directly. If I want to talk to this computer, it's pretty much going, this way. It's quite fast. Problem is, if the switch or router fails in the middle or the server, then the whole network goes down, and it can start to need a lot of cable. But this one's a bit confusing because compared to the other network that we're studying, which is mesh, it needs less cabling. But there are better ways of doing it than star or mesh, to be honest, in most environments. But you don't have to study those in this course. As you can see, it literally says star and mesh. So that's the main one to think about. Let's go on to the next slide. So obviously a mesh, or in this case a full mesh, is where they're connected to every single one, like this. A partial mesh, which is more like the internet, is where lots are connected, but they're not all connected to each other. So messages can be received more quickly if the route to the intended recipient is short. So if they've only got a short distance, it can be direct. That's quite quick. Messages have got a high chance of getting through because they can take multiple paths. And new nodes can be added without interrupting the others, but that's more of a boring one, really. So try and remember the first two, really. It's mostly that if you messages tend to get through because they can go around everything. They can be impractical to set up because of the high number of connections, and they do require a lot of maintenance because, more cables, more connections, more maintenance. Simple as that. Right, I've gone back to this one because it didn't feel like it sat in the right place there. I felt like it should be at the end. So this is the roles of computers on a network. So you've only got two ways to worry about. You've got peer-to-peer, and in that there is no central server. And that doesn't mean that you're not on a network that does have a central server. This could be like over the internet. You could be having like a virtual mini network over the internet. So basically, two computers could be talking to each other and neither one of them is essentially the server. Or they sort of act as both a client and a server. An example of this, like I said many times in lessons, is torrent downloading, where both of you are downloading a film. You can even be both downloading a film off each other because you could own half of it each and not even know. And torrents are set up so that you download random bits to try and make sure that the film doesn't get deleted if like one person turns their computer off. So basically, you're downloading off each other. That's an example of peer-to-peer. Companies like it because it's cheaper, because they don't have to use their own bandwidth, and they don't need staff to maintain the network. Also, if one computer goes down, it's probably okay because if the file's on lots of peers, then between them they should be able to collect, download the file between them. But the problem is there's no security at all, pretty much. Like, anyone can do what they want. Any idiot can put a virus onto the system without making a mistake. And basically, you can't back up any data because it's stored everywhere. The main layout, setup is client server. It's what big companies use. So basically, a server that does something is somewhere and then you connect to it. Examples of this are websites. They're hosted on a server and you want the website. DNS is an example of it, where you want the IP address, they send you the IP address, and others. The benefits to a company is that all files are in a stored location, backups and network security is controlled, you have control of that. It's more secure because the files are held on your server, and overall the quality of service is often better because people are downloading it from a professional company, and you can fix any issues. But this is the opposite really. It's expensive to set up, it needs constant maintaining. And if the server goes down, then the whole network's gone down, the system's gone down. So that can be bad. But at the end of the day, you are then it's gone down and can fix it. If in a peer-to-peer, the file, no one who's online has got the complete video or whatever, then no one's getting it. So you don't have, it's hard to have access to that. Often they're used in conjunction. Peer-to-peer is very rarely used completely on its own. Only in torrent downloading is it used on its own. And that's mostly because a lot of it's illegal and therefore companies won't go near it and do anything. So, but there you go, that's that unit, and good luck in the exam.